Functions. This question is of year 2018. 1 is variant. Question 9. Functions f and g are defined for x belongs to real number. This is the domain of both functions. X belongs to real number. Fx is equal to 1 over 2x minus 2 and gx is 4 plus x minus 1 over 2x square. Function fx is a linear function. Gx is a quadratic function. Find the points of intersection of the graphs y is equal to fx and y is equal to gx. We have to find the points of intersections of fx and gx. We will solve these two functions simultaneously. Fx is 1 over 2x minus 2 and gx is equal to 4 plus x minus 1 over 2 x square. Fx is equal to gx because we are solving simultaneously. So 1 over 2 x minus 2 is equal to 4 plus x minus 1 over 2 x square. Rearranging the like terms, rearranging this equation, writing in standard form, 1 over 2x minus 2 minus 4 minus x plus 1 over 2x square is equal to 0. Collecting the like terms, this becomes 1 over 2x square minus x over 2 minus 6 is equal to 0. This is a quadratic equation. We will solve this equation. First, multiplying each side by 2. So this becomes x square minus x minus 12 is equal to 0. Factorizing it, x square minus 4x plus 3x minus 12 is equal to 0. We get two factors, x minus 4, x plus 3 is equal to 0. X minus 4 is equal to 0, x is equal to 4. X is equal to 4 and x is equal to, from here, x is equal to 4 or x is equal to negative 3. These are the x coordinates of the point of intersection. We will find the y coordinates for each value of x. Putting this in fx, in any function you can put this value of x to find the value of y. Y is equal to 1 over 2x minus 2. Putting this value of x 4, we get y is equal to 0. So point of intersection is 4 0. Similarly, putting this value of x in fx, y is equal to 1 over 2x minus 2. Putting this value of x in here, we get y is equal to negative 3 over 2 minus 2. Y is equal to negative 7 over 2. So point of intersection will be uh, minus 3 minus 7 over 2. So these are two point of intersection. Next part of this question is find the set of values of x for which fx is greater than gx, fx greater than gx. Uh, Set of values means we have to give the answer in inequality. Fx is 1 over 2x minus 2. Gx is 4 plus x minus 1 over 2x square. Rearranging it, we get rearranging in order, decreasing order. This becomes 1 over 2x square minus x over 2 minus 6 is greater than 0. Multiplying by 2 each side, we get x square minus x minus 12 greater than 0. Factorizing, we get x minus 4, x plus 3. We have already done it in the above part, greater than 0. Critical values x is equal to 4 or x is equal to negative 3. Now we will find the set of values which satisfy the above inequality. Fx is greater than gx. X-axis, this is the graph. Quadratic, two values, smaller values, larger value, minus 3, smaller, larger is 4. The solution is, since the product of these two factors is positive, this means that function is positive. Function is positive. X minus 4 into x plus 3. Actually, this is a function or the value of y. This is greater than 0 means positive. Positive will be, function will be positive for these values. Greater than 4 or less than minus 3. So set of values in this question, x is greater than 4 or x is less than minus 3. Now the next part of this question is find an expression for f g x and reduce the range of g. First we have to find the composition of two functions f and g. F g x, f and g both are given. We have to find f g x. F g x, now putting the value of gx here, this becomes f, and gx is 4 plus x minus 1 over 2x square. So we will write here uh, gx, that is 4 plus x minus 1 over 2 x square. Now in the original function fx, 1 over 2 fx is 1 over 2x minus 2. So in place of x, we will put this value. So this becomes 1 over 2, 1 over 2. Look at this function fx, 1 over 2x. In place of x, we will put this value 1 over 2, 4 plus x minus 1 over 2 x square in the function fx 1 over 2x minus 2. So here is minus 2. Now we will simplify it, multiplying by 1 over 2 with this bracket. Each term will be multiplied by 1 over 2. This becomes 2 plus x over 2 minus x square over 4 minus 2. This is cancel out. So fgx will be minus x square over 4 plus x over 2. Now this is fgx, and now we have and reduce the range of fg. Now we have to find the range of this function. Clearly this fgx is a quadratic function. So for the range of this function, we will find the vertex of this parabolic graph. So then we can deduce the range of this function. Vertex, how we will find the vertex? For vertex, x coordinate we will find, then putting this value of x in the function, we will get the value of y. So x will be vertex, x coordinate of the vertex will be minus b over 2a. A is the coefficient of x square, b is the coefficient of x. So look at this function f g x. X will be equal to minus b over 2a minus 1 over 2 over 2a. 2 into a is minus 1 over 4. So x is equal to 1. Now putting this value of 1 in the function f g x, we get the value of y will be minus 1 over 4 plus 1 over 2. So value of y is 1 over 4. This is the range. Now we sketch this graph here to show the range of this FGS. FGX की हमने range find करनी है, तो so vertex coordinates are 1 1 over 4. 1 1 over 4 are the vertex coordinates. This is 1 and this is 1 over 4. So graph will be, because the quotient of x scale is negative, so graph will take the maximum value. This is the graph, and clearly the range of for this graph is this. This arrow shows less than or equal to 1 over 4. So the range of FG is less than equal to 1 over 4. This is the range of this FGX. The next part of this question is part 4. The function h is defined by hx is equal to 4 plus x plus minus 1 over x square. This is the same function as gx. hx is the same as gx, but domain is different. X is greater than or equal to k. This is the domain for hx. hx is equal to 4 plus x minus 1 over 2 x square. This is the domain. X is greater than or equal to k. Find the smallest value of k for which h has an inverse. So we know that inverse is possible only if the function is 1 to 1. So first uh, we will find the vertex coordinates. Vertex coordinates, x coordinate for the vertex is equal to minus b over 2a. First we arrange it. Minus 1 over 2 x square plus x plus 4. Clearly, x is a is minus 1 over 2. Coefficient of x is 1, that is b. Constant term is c. So x is equal to minus b over 2. X coordinate of the vertex will be equal to minus b over 2a. A is negative 1 over 2. So x is equal to 1. Putting this value of x is equal to 1 in each x is the y. So y will be equal to minus 1 over 2 plus 1 plus 4. This becomes y is equal to 9 over 2. Now this is the sketch for this graph, for this function each x. Uh, Vertex coordinates are 1, 9 over 2. This is 1 and this is 9 over 2. Since the coefficient of x scale is negative, so graph will be open downward. So we have to find the smallest value of k. You know the k is actually the value of x. So this is the value of x. The smallest value of x for which function is 1 to 1 because each has an inverse. Inverse is possible only if the function is 1 to 1. So this is the smallest value of x. This is the smallest value of x. So k is equal to value of smallest value of k. K actually the value of x. So smallest k is equal to 1.